Hey there, good afternoon, good morning, good evening, who knows where you are, class. But this lecture is 5.3. We're talking about medians, altitude, centroids, and orthocenters. So if you're following along in your book, this is a good place to start. So median is to centroid as altitude is to orthocenter. And you might be thinking, what are you talking about, Mr. Rising? Well, follow along with your vocabulary if it helps, because you need to know what a median is to understand a centroid, and you need to know what an altitude is to understand an orthocenter. So just to review, a median connects the midpoint of a segment in a triangle to the vertice on the opposite side, right? So again, midpoint to vertice. Well, when you do that in a triangle and you connect each midpoint to the opposite vertice, you get a point called the centroid. And what's so cool about the centroid is it is the balance point of a triangle. So you take a triangle, you can balance the triangle on that particular spot, which is pretty cool. The centroid theorem states that that point occurs 2/3 away from the vertices. So what I mean by that is, if this entire length here is 15 from A to Y, the length of A to P is 10. If the length from B to Z is 9, the length from B to P is 6. Right? So you get the idea that this point P is 2/3 of the way from the vertice to the midpoint on the other side. So what does that look like? You want to try to find a centroid? Let's do it. First of all, let's find midpoints here. And I'm going to go to the board so we can do this a little bit easier. So when I look at this segment here, QP from 0, 8 to 3, 0, what I really want to do is find the point right in the middle. And you'll notice here, this is 3 units wide, and you can think of it as 8 units high. So it's going to occur halfway between 0 and 8, which is 4, and halfway between 0 and 3, which is 1.5. So right here, and let's just make a little mark here. I'm going to make a point. So I know it's going to occur somewhere on that segment. Well, cool. Now, when we were doing this the other day with other triangles where we're bisecting angles and we're bisecting sides, we found that you only have to do 2 of the 3 because, again, where 3 lines intersect, 2 of those lines also intersect. So now what we need to do is pick another side. So let's take a look at this side right here. And again, I'm going from 0, 8 to 6, 4. So what's the vertical difference between the two? I'm going from 8 to 4. So halfway between 8 and 4 is 6. So it's going to occur somewhere on this line. And of course, when I do it horizontally between 0, the x-coordinate, and 6, the y-coordinate, it's got to be at 3. So right here, boom, and I can draw that straight down because, again, it's a median. It's connecting midpoint to opposite vertice. You can see that clearly these two medians come together at the point 3, 4. So the median is 3, 4. I'm sorry, the centroid is at 3, 4. Now, what does this have to do with averages? Well, prepare to be blown away because this is what's so cool. Average the x-coordinates, average the y-coordinates. So my x-coordinates, when you look up here, I've got 0 plus 6 plus 3 divided by 3. That's 9 divided by 3. Of course, that's 3. Do the same thing for the y-coordinate. I've got 8 plus 4 plus 0 divided by 3. And that's 12 divided by 3, which is just 4. That is exactly. The balance point is the average of the x-coordinates and the average of the y-coordinates. Way cool. Now, the next thing we need to talk about are altitudes. Altitudes are the height of a triangle. Well, one of the questions that comes up is, Mr. Rising, which side is the base? And actually, every side could be the base. But from that base, the altitude is a line perpendicular to that base that passes through the vertice on the opposite side, the corner on the opposite side. Well, what that means is sometimes these altitudes occur outside of the triangle, and sometimes they occur inside the triangle. What I mean by that is, for example, line or segment YQ is an altitude, right, from RS, and it passes through the triangle. But when you look at this point, this line RX here, you can see it's the altitude of QS, but it's drawn outside of the triangle. Anyway, where these three altitudes come together, that point is known as the orthocenter. It's a very cool kind of structure. I'm going to pause this lecture here, and when we get to class together on Thursday, I'll show you an example about how to find the orthocenter given 3 points.